this semester I'll be teaching you two paper HCC 8 which is multivariate calculus. It's unit 3 and 4 which contains vector calculus. I'll teach this one, and unit 1 and 2 it also has multivariate calculus that will be taught by GR sir. Okay, and another paper is SEC 2 which contains C programming. So today in online class I'm starting this one HCC 8 vector calculus. Very easy topic. In previous semester, probably in second sem, I have learnt you vector algebra, right? That there was about the vector, what is vector, dot product, cross product, vector triple product, scalar product, everything was there. So now it is the second part of this thing which is called vector calculus or vector analysis. Here you need to learn about vector integration, which you have already learned a few things about vector line integration. This is also here along with surface integration, volume integration and all. Okay, this paper is quite easy and quite scoring paper. Okay, so for this paper or for this topic vector calculus, you need to follow two books. Number one is Ghosh-Maiti vector calculus and number two is Spigel of SOM series. Okay, I have the PDF of this Spigel book. I'll give it in the group, and for Ghosh-Maiti I'll send you the photo of the pages part by part. Okay, so if you don't have the hard copy of these books, no problem. So let's start with the first chapter. First chapter is here gradient, divergence and curl. Gradient, divergence and curl. You know a little bit from the previous vector algebra. So the first topic is nabla operator or Dale operator. Dale oblique nabla operator. Okay, which is denoted by this sign. Okay, so if you take any function, say f, then nabla of f or Dale of f, that is known as gradient of f. Okay, and what is the value of that nabla operator or that grad thing? The value is I cap del del x plus j cap del del y plus k cap del del z. Okay, so it's an operator and it is a vector because it contains all these three components I, j, k. So if you apply this over the function f, that is grad f, it will take the value I del f del x plus j, obviously j cap, del f del y plus k del f del z. Okay, this is called grad f. This is the first thing. Now suppose this f, it has three components, that is f1 I cap plus f2 j cap plus f3 k cap. Then how to calculate grad f? Very simple. This is I del del x of this whole thing. F means that f1 I cap plus f2 j cap plus f3 k cap plus j cap into del del x, the whole thing for f, plus k cap del del x, the whole thing. Okay, this is how we calculate grad f. Now next thing is called the operators with different signs. Now first we consider grad dot. Okay, so suppose there is some function f, some vector f, and we are trying to consider this thing. You might use the vector arrow sign over this nabla operator because it's a vector. So if this quantity you need to calculate, how to calculate it? Okay, very simple. I cap del del x plus j cap del del y plus k cap del del z, then dot f, right? Now this f must have three component, say f1, f2, f3. Then how to find their dot product? Product of i's component plus product of j's component plus product of k's component. So that will become That will become del f1 del x plus del f2 del y plus del f3 del z, right? Similarly, if you want to calculate this nabla operator cross some vector function, say f, this is also vector. Okay, so this one, how to calculate it? This is also very easy. Just put their values: I cap del x plus j cap del y plus k cap del z cross this f also must have three components, so f1 cross comma f2 comma f3. Now how to calculate their product? This one, first row I cap, just computing the cross product. J cap, then first is del x del y del z and f1 f2 f3. Okay, so this is how we calculate all these things. Now you might get another thing which is called del square. That means this del operator dot this del operator. How to calculate its value? Its value is very simple. Put the values: I cap del x, j cap del y plus k cap del z dot I cap del x plus j cap del y plus k cap del z, right? Find the dot product, this one into this one, so del 2 del x2 plus this one into this one, del 2 del y2 plus del 2 del z2, right? Check, it's an operator but it is not a vector, because we know dot product of two vectors become a scalar. Okay, so this is how we compute all the operations with that nabla operator. Now let's solve few examples. Example number 1, mostly the example is there in this chapter. If f vector equals to x square I cap plus y square j cap plus z square k cap, then calculate grad dot f and grad cross f. Okay, so f has three components. First component is x square, second component y square, third component z square. Very easy to calculate. First starting with grad dot f, that means I cap del x plus j cap del y plus k cap del z into this f's component x square I cap y square j cap plus z square k cap, right? Find the dot product. This del x into x square, that means del x of x square because it's an operator, del y of y square plus del z of z square. Its second partial derivative of first order, that will be 2x plus 2y plus 2z. This is the answer. Next, this cross f. So we just took the formula how to calculate the cross product. It is under determinant I cap, j cap, k cap. Then first, this one is first, so we need to put this component first, del x, del y, del z, and next one is x square, y square. The components of f, x square, y square, z square. Now expand it. You know how to expand the determinant. Answer will be 0. Calculate it. Okay. So this is how we calculate these two things. Now it has a particular name, that any vector f and the dot product of the nabla operator, it has a particular name which is called divergence of f. Okay, so whenever I say divergence of f or div f, you need to understand that means nabla operator dot the function, vector function f. Okay, and this thing nabla operator cross f, it also has a particular name which is called curl f. Okay, so whenever I say curl f, you need to understand that means nabla operator cross the vector function. Okay, now if sometimes we check that this divergence of f divergence of f becomes 0, then the vector is said to be solenoidal. Okay, so what is the definition of being a vector function becoming solenoidal? The divergence of f must be equals to 0. And another thing you need to learn, that is if curl f becomes 0. Curl f is a vector, so we need to put it 0 vector. So when curl f becomes 0, then the vector is called irrotational. Okay, if divergence f 0, then solenoidal, and if curl f equals to 0, then it is called irrotational. Now let's solve one example using that solenoidal and irrotational thing. Example 2. Find the constant a, find the constant small a so that the vector v equals to x plus 3y I cap plus y minus 2z j cap plus x plus az k cap becomes solenoidal. Okay, so find the constant a so that this vector becomes solenoidal. Now what is the condition of being a solenoidal vector? The answer is the divergence of that vector, that is divergence v, will be equals to 0. And what does it mean by divergence v? That means nabla operator dot vector v function must be equals to 0. So find it. What will be their divergence v, that is dot product with the nabla operator, so it will become del x of x plus 3y plus del y of y minus 2z plus del z of x plus az equals to 0. Okay, here you need to write one line, I'm skipping it, that is putting the value of nabla operator dot putting the value of v vector function, then write this line. Okay, I'm just skipping it here. Calculate it. This will give you 1 plus a equals to 0. So a becomes minus 2. Okay, this is the answer. Similarly, question come that is find the constant a when curl v equals to 0. Right? The same example you can solve it. Then you need to consider curl v means nabla cross v. So then you need to consider this function and then calculate the value of the constant. Got it? Next one, example 3. Find divergence in bracket grad phi. Divergence in bracket grad phi where phi equals to 2x cube y square z to the power 4. Okay, phi is not a vector, it's a scalar quantity. You need to consider divergence grad phi. Let's start it. So divergence grad phi. First we calculate that grad phi thing. Okay. Okay, before doing that, let's write it. Divergence of grad phi. Okay, divergence of some quantity, that means nabla operator dot that something, right? So nabla operator grad phi, we can write it. Now check. This is nabla operator, and how can we write grad phi? We can write it like this. Okay, now there is dot product, it is a vector product, right? So under this dot product we can put two vectors only. Phi is a scalar, this nabla is a vector, nabla is a vector, so we can put a bracket over here because actually we need to multiply this two, because dot product is not defined for any scalar thing, it is defined for vector quantity. So here phi is the scalar, so if you put a bracket over here, nothing will be changed. So this dot product between two nabla operator, that means nabla square operator, right? Now what is the value of nabla square? We already calculated it. That was del 2 del x2 plus del 2 del y2 plus del 2 del z2 over 5. Okay, that means open the bracket, del 2 phi del x2 plus del 2 phi del y2 plus del 2 phi del z2. Okay, now what is the value of del 2 phi del x2? Calculate it. Phi is 2x cube y square z to the power 4. Calculate it over side, then put it over here. Okay, del 2 phi del x2, that is del x of del phi del x, right? Put the value, that was 2x cube y square z to the power 4. So after we will get 6x square y square z to the power 4. Again 12x y square z to the power 4. This is, we get the value of del 2 phi del x2. Similarly, you need to calculate the value of del 2 phi del y2, del 2 phi del z2, then find their sum, you will get the answer. Okay. These are few examples on this topic. Now, some of the examples come with R. Then how to calculate that type of examples. Okay, R means any arbitrary vector. So whenever the problem including R, we need to take R means any arbitrary vector. So we will take R means x I cap plus y j cap plus z k cap. Okay, then what will be mod R? Mod R will be root over x square plus y square plus z square, right? Then let's solve one example. Example 4, that is, given R be any vector and C be any constant vector. Given R be any vector and C be a constant vector, then prove that number 1, divergence of R will be 3, divergence of C will be 0, curl of R will be 0, vector obviously, curl of C will be 0 vector, divergence of R cross C will be 0, but curl of R cross C will be minus 2C. Okay, all these things 1, 2, 3, 4, 5, 6. Total 6 things you need to prove for any vector R and any constant vector C. Now whenever R is any arbitrary vector, we know how to take R. R will be xi cap plus yj cap plus zk cap. But for C it is a constant vector, so we need to take that C is a, say, c1 I cap plus c2 j cap plus c3 k cap. Okay, where c1, c2, c3 are all constants because it's a constant vector. Now let's start. The first one, divergence R. Divergence R means this nabla operator dot R vector. So nabla operator, put the value, dot that R vector. R means xi cap plus yj cap plus zk cap. Put it, del x of x plus del y of y plus del z of z. So this is 1 plus 1 plus 1 equals to 3. Okay, this is the answer, that is divergence R will be 3. Now we need to put that divergence C will be 0. Divergence C vector, that is nabla operator dot C vector. So I cap del x, j cap del y plus k cap del z dot c1 I cap plus c2 j cap plus c3 k cap. That is del x of c1, del y of c2, del z of c3. Obviously it's a constant, its differentiation will be 0, so 0 plus 0 plus 0, this is 0. Got it? So next to I'm leaving at homework, that is curl R will be 0 and curl C will also be 0. Now let's put the prove the next one, which is divergence of R cross C will be equals to 0. Let's check what is divergence of R cross C. That will become grad dot R cross C. Right? Now this is I del del x plus j cap del del y plus k cap del del z dot. You first need to calculate the value of R cross C over side, then put it over here and then find their dot product, that is del del x of some quantity plus del del y of some quantity plus del del z of some quantity. Okay, and you will get the result. Similarly, you can calculate the next one also, that is curl of R cross C will be minus 2c. Very simple examples. Next we will solve few more example on using R. Example 5. Find grad phi if number 1 phi equals to log mod R and number 2 phi equals to 1 by R. Okay, so R is any arbitrary thing. We need to take R as xi cap plus yj cap plus zk cap. Then mod R is root over x square plus y square plus z square. Log mod R will be log of root over this whole thing, that is x square plus y square plus z square, its whole to the power half. Now we know by the log property we can put that half over here. Okay, now we need to consider grad phi. That means I cap del del x plus j cap del del y plus k cap del del z over this whole quantity, half log x square plus y square plus z square. Okay, that means I cap del del x of this quantity, half log x square plus y square plus z square plus j cap del del y, this whole quantity, half log all this thing, plus k cap del del z of half log this whole quantity. Okay, now calculate it. I cap, if you calculate it with partial derivative with respect to x, what will you get? Half of derivative, it will be 1 by x square plus y square plus z square, and then x parts derivative, which is 2x. So you will get this thing. Next, from the next part, j cap into half of 1 by x square plus y square plus z square into 2y. Okay, 2 got cancelled out. Similarly for k cap also. Okay, this whole thing. Now simplify it and okay, let's solve it. Let's check. That will be the same thing, 1 by 2 into 2z by x square plus y square plus z square. So 2 got cancelled out. Now if you simplify it, what will you get? Let's see. From the first part we are getting x by x square plus y square plus z square into I cap. Similarly from this thing. So let's write it. If you write over here I cap x by x square plus y square plus z square. j cap y by the same thing, x square plus y square plus z square, and k cap z by same thing. Okay, so we can write it x I cap plus y j cap plus z k cap by x square plus y square plus z square, right? Now what is that mean? The numerator, this means our r vector, and the denominator means modulus of r vector its square, right? So the answer is r vector by mod r square. Okay, this is the answer. Next one, number 2, that is phi equals to 1 by r, that will be, I'm leaving it as homework. Okay, next example 6, show that grad r to the power n equals to n r to the power n minus 2 into r vector. Whenever they are saying only r, that means mod r. Okay, and when they are saying mod bold r or over this vector sign r, that means r vector. Okay, so we need to prove it. Let's say let r vector is xi cap plus yj cap plus z k cap. Start with the left hand side, nabla r to the power n. That means nabla this r only single r. Okay, that means this is modulus of r. So r vector's modulus is x square plus y square plus z square. It's root over, right? So root over whole to the power n. That means grad x square plus y square plus z square whole to the power n by 2. That means if you put the value of grad, we will get I cap del x of whole this quantity z square whole to the power n by 2 plus k cap del y this whole thing to the power n by 2. Similarly plus, sorry not k, this is j, then k del z of whole to the power n by 2. Okay, so let's calculate the first one. That will give you partial differentiation with respect to x. So n by 2 whole to the power x square plus y square plus z square whole to the power n by 2 minus 1 into the derivative of x, which is 2x, this whole thing, right? Plus for j cap we will get the same thing, n by 2 this whole thing whole to the power n by 2 minus 1 into 2y plus k cap the same thing. Okay, so we can take something common, that 2 will get cancel out, so we can take common n into x square plus y square plus z square whole to the power n by 2 minus 1. Check this occurs in 3 terms, we can take it common. So here it will give you x I cap from the first term, y j cap plus z k cap, right? That means our r, and this means our mod r square. So n mod r its square, I'm writing it single r here as it is mod r, sorry square whole to the power n by 2 minus 1 into this is our r vector. Okay, so after simplifying we are getting r to the power n minus 2 to not dot r cap. Okay, so this is the answer.